session because otherwise today so let me share the screen first. So okay, today I'm planning to teach you how this ESP transport and tunnel mode works. So before that, let me show you one thing from yesterday's session. So that is, let me initiate a ping request from this. I think we configured tunnel mode, right? At the end of the session, we configured tunnel mode, I guess.
Yeah.
I think age tunnel mode, right? Let me go to IPSEC yeah, tunnel mode is here. Okay, so then let me show you one thing. So then I'm going to ESP part. Set my red out is down, so I don't enable. When it comes to SPD and SAD, did you see that I put a short text that is when it comes to SPD, security policy database, what to protect, and when it comes to SAD, that means how to protect. So that is the the very basic way to understand the two concepts. So what to protect means what networks, what source and destination should be IPsec treated. How to protect means how to do the IPsec. What are the algorithm? What are the keys should be used in order to do the encryption and decryption. So if you can, just keep that in mind, I think that will be easy for you to understand when it comes to exam. So wait some time. So until it is getting started, so let me draw the ESP thing. So I think it's better if you can do the ESP transport mode first. That is ESP transport. Sorry, ESP transport. So when it comes to ESP transport mode, this is the packet. Here we have IP header. This is IP header. And here we have ESP header. And here we have TCP. So if it is TCP, or otherwise if it is UDP, so then the UDP header. Okay. So here we have data. And here ESP trailer. ESP trailer. And here ESP ICV. Integrity check value. This is the ESP transport mode packet. So I think you can understand why we do not have two IP headers, because we are having two IP headers only in the tunnel mode.
Yes.
Okay, so then here when it comes to integrity check, that these fields are included, including ESP header up to ESP trailer. This is integrity checked. Integrity checked. So when it comes to encryption part, it is starting from the TCP header up to ESP trailer. This is encrypted. So this is the basic ESP transport mode packet, ESP packet. So let me go to my lab setup. Yeah, now ping is fine. So what I want you to notice is, so let me go to this intermediate router. Let me take a capture. Here, now you can see ICMP packets, right? But here, once you open it, only you can see here, you can see the authentication header. But when it comes to this, protocol field, that is mentioning ICMP, not the AH. Can you understand the reason? I mean, why you cannot see AH instead of ICMP? Because the thing is, actually, since authentication header is not encrypted, I mean, these data packets are not encrypted. So because of that, this Wireshark can see these are ICMP packets. So that's why it is mentioning this is ICMP. If it is encrypted, so then so let me go back to the diagram. So let's say if this is encrypted, so then this IP header and the ESP header and the ESP ICV is the only part that is not encrypted. All other data, all other TCP and data and the ESP trailer is encrypted. So then this Wireshark should not be able to identify the protocol as let's say SSL or HTTP or whatever, because the Wireshark should not be able to identify even the port number because it is also encrypted. So then it should be identified as ESP. Okay, so that should be our observation. That should be our observation. But here in AH, since it is not encrypted, so we can see the protocol type. So that is ICMP. Okay. So do you have any questions regarding that? Irishaka?
No, fine.
Yeah, ask me, Anushana.
Yeah, the thing is, whether we can check if now we didn't encrypt it now.
Yeah.
So once we encrypted, we can check it, right? From the Wireshark.
Yeah. From the Wireshark, we can see that. So that's why I explained earlier. So then we'll check. So let me go to the VPN gateway. So let me change this. Actually, we have to change this because actually we are going to no, we have to go to Raccoon as well, because we are going to use not the tunnel mode, we are going to use transport mode. So let me go to Raccoon first. Here, so this is fine. This is the phase 1. So anyway, phase 1 should be negotiated between the VPN gateways, not the VPN gateway actually. So let me draw the diagram about the transport mode first. That would be fine for you. So here our now current setup would be here we have our VPN gateway, but we are going to treat this as a let's say web server. And here we have a IPSEC tunnel, and this is our second VPN gateway, and this is, let's say, this is a database server. Okay, so then these are the two endpoints. So this is ESP transport mode, because when it comes to transport mode, that should be host to host, not the network to network. The reason is we don't have two IP headers. So once the packet comes here, so the only one IP header is going to be removed. So then this packet cannot be routed through the network since it does not have a IP header. So then packet should be destined to this machine. So that is, I think I explained yesterday.
Yeah.
If you have any question, just ask me. If you have any, queries. Okay, so let me go to configuration here. So then I had to, this is phase 2 details. So then I had to change this IP address, because now our the actual there's a term in IPSEC, but I think in our notes that is not there. Normally in production we say encryption domain. So encryption domain means so whatever the let's say in this scenario, these two are the encryption domains, these two IP ranges. But let's say this is tunnel mode. If this is tunnel mode, so then our encryption domain should be, let's say we have Windows machine. Let's say we have another Windows machine. So these two networks are the encryption domains, because actually those two networks are going to be encrypted using IPsec tunnel. So that is called encryption domain. So let me go to Raccoon, and here now our encryption domain is different one. So that means since this is host to host, then we have to put our VPN gateway IPs, because those two are going to have a host to host connection. So then 172.16.1.1. Sorry. Let me that. One seven two 16.1.1. Sorry, because of my writing pad, my cursor is moving. One seven. Shit. 172 16.1.1, and this should be 172 16.2.1. Okay, so now these two are the encryption domains. So these are the phase 2 details. Okay, so let me save that. So let me restart it first. Service raccoon restart. It's fine. So let me go to IPSEC tools. Here also I had to change this is security policy database, right? I think you can remember that. So here we had to tell what to protect. Okay, so what to protect. So in this scenario, the protection should be enforced to VPN gateway IPs.
VPN gateway.
Yeah.
172.
16.1.1.
Oh.
172 16.2.1. Okay, so here since we are using ESP, we have to change ESP and the transport. So not the tunnel. Should be
And those
transport.
two IPs.
Oh, sorry.
Oh.
It should be sample.
It's okay. Transport. Okay, transport. So then we have to remove this tunnel IPs. This block should be removed.
Yeah. Oh.
Should be removed. Okay. So then let me save first, because otherwise something is going to be removed. So then I have to, discard this. So then this should be changed again. Udeshika, can you remember that, bidirectional and, unidirectional thing? When it comes to phase 1, it is bidirectional. When it comes to phase 2, it is unidirectional. So, I mean, we have to have virtual connections for both ways. So we cannot use one way and we can communicate bidirectionally. So we have to have two ways. So yeah, so this is the inbound connect direction. 7 to 62.1. 7 to 1. And then this should be ESP. And this should be transport. Oh shit. More controls. Okay. Sport. This should be removed. Okay, so let me save that. Anyway, when you are editing configuration files, it's better you can have a original file copy it to some other location. If otherwise you are going to lose the basic configurations. Set key restart. Okay, I have restarted that. So let me go to the VPN gateway 2. Actually, in this scenario, these are not acting as VPN gateways. Actually, these are just hosts. Okay, let me go to Raccoon configuration first. Okay, this is phase 2. Seven to 16. 7 to 16. 1.1. Okay. Sorry. Okay. It's done. See this on. 7 to 16, 2.1. 7 to 16, 1.1. So let me change the protocol. ESP, and this should be transport. Spot. And the tunnel should be removed. Here. 7 to 16, 1.1. Yeah.
Question.
Yeah.
අර phase 1 එකේ key එකක් අර encrypt වෙලා ඒක phase 2 එකට use කරනවා කිව්වනේ.
Oh.
එතකොට ඒක ESP එකටත් එහෙමමද?
Oh, I'll explain in English because of Anushana.
Sure.
So
Sure,
so
no
when
worries.
it comes to phase 1, so they and Ireshaka asked me that whether the IPSEC use this pre-shared key in order to do the encryption. No, actually the pre-shared key is used in order to authenticate the peers, not for the encryption. So then they derive keys. Actually, there are so many keys. I think I showed you that yesterday. I retrieved a key and I decrypted the phase 2 negotiation. So they derived a key in phase 1. So they are going to use that key in order to encrypt the phase 2 negotiation details. Negotiation details means actually the proposal communication. So they are going to encrypt that. So that means the phase 2 encryption. So proposal negotiation means quick mode.
Yeah.
So in quick mode, they are going to derive another set of keys, and they are going to use those keys for the actual data communication. When it comes to actual data communication means, if it is age, there is no encryption, so only the integrity. But when it comes to ESP, so encryption and integrity both available, but except the IP header integrity, because in ESP we do not have IP header integrity check. So then those keys derives in the quick mode is going to be used for the phase 2 actual data communication in ESP. So I'll show you, because I'll show you how to decrypt those things, and I'll show you the packet structure, because when it comes to ESP you cannot see the whole packet structure as well, because since the encryption you cannot see the what I have drawn in the diagram. So let me show you that. So here, let me change to ESP. This should be transport. And this should be remote. It's fine, right?
Yeah.
Okay. Service. Okay. So let me go to. This is the machine we should initiate a ping. So I think we have ping here. We have to stop that. Ping 172.16.2.1. Now ping is working. So let me go to internet router and let me stop this and start another one. So you should be now. You can see ESP, because actually once you start open the packet. Can you see the structure? Because here you can you see the TCP header? No, you can't see the TCP header. Can you see the data part? No, you can't see the data part. So because everything is encrypted. So that's a problem. Not the problem, actually. That is the way that it works due to the encryption. So once I click here and check the protocol, sorry, check the structure of the packet. This is Ethernet, this is IPv4 header, and this is the ESP header. So that is the only thing you can see. You cannot see, let me go back to the diagram. You cannot see this TCP header data. These things all are encrypted. So let me decrypt the packet and show it to you. Let me go to the window. Now, Deshika, I'll be able to show you, I mean, evidence for this, bidirectional, sorry, unidirectional thing and the SP, I think, because I explained to you that when it comes to phase 2, that is unidirectional, and also the security parameter index is being used in order to identify the, whatever the packet receiving at the receiver end or sender end, in order to relate that to security association database. So they are using security parameter index. So what keys should be used, what algorithm should be used. So those things should be found using a security parameter index, and also source and destination. Because I think Ireshaka explained that when it comes to that, we have three things: security parameter index, source and destination IPs, and security protocol. These three is going to be used in order to identify the security relevant security association entry for decryption or encryption purposes. Okay, I'll show that to you. Except for RM state. So this is the security association that are being used in order to do the encryption and decryption. This is from 172.16.1.1 to 2.1. This is from 172.16.2.1 to 1.1. There are two security associations. You just observe this. So when it comes to encryption, this is the encryption algorithm, but you just take the key. This is the key for this association, but this is the key for this second association. So there are two different keys. So that means this is the SPI value, security parameter index. This is one value, and this is somewhat different value. So that means we have to have these three things: source and destination IP, security parameter index, and the protocol. Okay, this is protocol ESP. Ireshaka, can you see this?
Yes, Mali.
Yeah, because you explained that yesterday. This is the protocol. This is the protocol, and this is the security parameter index. And this is a source and destination. So those things should be used in order to identify the relevant security association entry in order to encrypt or decrypt specific packet, which is enforced by the security policy database. Because I explained to you, I explained you security policy database means what to protect, and security association database means how to protect. Yeah, that is the way that you have to remember this. So let me decrypt this direction. Okay, so then I had to get the security parameter index first. Copy, and let me go here, and you have to go to edit preferences. Actually, this decrypting thing is not relevant for you, but the thing is, actually, I just want you to show. I want to show you the exact encryption thing, and also want to show you the exact packet structure, because since this is encrypted, I cannot show you the exact ESP packet structure. So because of that, I'm going to decrypt this. Here I have to select the ESP. This is ESP. I'm going to edit this. I have to create an entry. This is the protocol IP, and this is a source IP 172.16.1.1, and destination IP 172.16.2.1. This is the security parameter index, and let me check the encryption algorithm. That is 3 days. So encryption is 3 days. So this is triple days. Okay. So encryption key. So I have to copy that. 3 days. This is the encryption. This is the encryption key that is used. Actually, Akka, you can understand, because I think I showed you that yesterday. I used a pre-shared key that is C²123, but the encryption key is not that one. This is somewhat different one, derived by the this IPSEC daemon. Okay, so then the authentication is HMAC MD5. So authentication is somewhere here. Okay, HMAC MD5 and authentication key. This is the authentication key. Okay, so let me click OK and OK. Now can you see? Now you can see ICMP. See?
Yeah. Yes.
Now it has been decrypted, but I'm not going to show you ICMP because you know ICMP since it has no TCP header and all. So let me go here, and I think we have a web server. I think time is going to be run out, so let me stop and start the session again. Okay, I think I have 10. No, I have 10 minutes. So let me show this and stop. So let me go to web server. Because actually I want you to see 172.16.2.1. Okay, so let me refresh few times and let me stop the ping. So that's easy. Okay, so let me go here. See, now you can see HTTP. Okay, can you see this? Now it has been decrypted. This is the packet encapsulating security payload, and within the encapsulated security payload, you can see the TCP header and the data. So previously it was encrypted. So let me show you one thing. So this is the packet. Okay. So let me go here. So let's see, this is the packet. So let me remove, let's say, encryption key. So I'm going to remove the encryption key here. Protocols ESP. ESP. Okay, here. So I'm going to remove. Oh, let me add some character here. Let's say 11. I added that. Let me click OK. Okay. Sorry, no, I had to remove it. Edit because there's a predefined length for this field in this ESP protocol. ESP. So let me remove this. Not that is an authentication key, right? Sorry, not the encryption key. So let me go to encryption key. So let me add something here. 5. Okay. See, now it is ESP, not the SSLO, HTTPO, ICMP, anything. Now, once you open this, you cannot see anything because let me go back to the diagram. Here, this part, TC, including TCP header, data, ESP trailer, those things are encrypted. So that's why you cannot see those things. So, but once I, decrypt it, you can see those details. Protocols ESP. Shall we start the session again, because I think it's going to be expired.
Okay.
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 Stop. So you can see the screen, right?
Yes.
Yes.
Okay. So okay. Now let me go back to this packet capture. Okay.
Start recording.
So I had to correct the key because I changed the key. Let me go to ESP.
You started recording?
Yeah, I started recording.
Yeah.
Yeah. Okay. So I'm removing the extra characters here. So let me click OK and OK. Now it's you can see now the actual data can be seen because the ESP has been decrypted now in the Wireshark. So you can see this encapsulating security payload. This is the SPI value. So this is going to be used for in order to identify the packet related to SAD, Security Association entry or database entry. So this is a ESP. This is IC value. This is the integrity check value, and then this is the what do you call TCP header. Now you can see the TCP header. So if you are going to TCP header, you can see the destination port, source port, and sequence numbers and all, acknowledgement numbers and all. So then you can see the data. This is data. See, this is user agent access. This is encoding, and you can see all the data. This is the URL and everything. So then you can see this packet structure here. This is a packet structure. So you can see TCP control protocol and hypertext transfer protocol. The hypertext transfer protocol means actually the data. This is the encapsulating security payload. Do you have any questions regarding this? Irishaka, everything fine?
Yeah.
Yeah.
No worries.
Anushana, Udeshika.
Fine.
Yeah, no worries.
Okay, so that is that. So that means that is ESP transport. So now I'll explain ESP tunnel mode. So let me draw the diagram here. Here, so now our the network should be changed, because here we are going to have a backend server. I mean, backend server means we have a, let's say we have a web server here, and it is connected to a VPN gateway. Because when it comes to
I say for
Yeah.
the ESP transport mode and AH transport mode.
Yeah.
What is the difference in there? Which one is best?
Yeah,
ESP transporter.
Yeah, but
transport.
let me explain that, because when it comes to, let me draw both the structures and explain. I think that is better. So let me draw the edge transport first. Okay, so when it comes to edge transport, this is the packet structure. You have IP header here, and you have edge header here, and you have data. Sorry, TCP header, and you have data. Okay. So here the thing is, when it comes to edge, the whole packet is checked for integrity, including IP header.
Yeah, IP. But for the ESP transport, not the IP header, right?
Yeah, ESP transport, not the IP header. But the thing is, when it comes to edge transport, you cannot use this for network address translation. So let's say in drawback, because let's say in the exam, let's say you are going to have a scenario where they say network address translation is a must for the IPSEC tunnel. So in that scenario, you cannot use edge transport or edge tunnel. You cannot use, because since the IP header is going to be changed, I mean altered by network address translation device, so the packet is going to be invalidated from the responder or the receiver end. So in that scenario, you cannot use edge tunnel or edge transport or tunnel for NAT. Yeah, if NAT is required, so this is not the solution. So I think I saw one of the papers. This question was there. They mentioned network address translation.
Okay.
Yeah.
The diagram question, right? They drawn a diagram and
yeah. I think there was something like that.
Once we done, we will do the question paper.
Yeah, sure.
Regarding it.
So,
okay, you can.
Yeah. Yes. Then that means edge tunnel is also we can't use, right?
Yeah, edge tunnel. Let me draw the diagram for the edge tunnel, so then you can understand. So this is
there's a new IP header and as well as the old IP header.
Yeah, that's a difference, because here we have this is a new IP header, and here we have edge header, and this is the old IP header. Here we have TCP header, and here we have data. So in this scenario also, you cannot use NAT, because this total packet is going to be checked for the integrity. So if in NAT in a network address translation solution, this new
Yeah.
IP header, either source IP or the destination IP is going to be changed.
That's the case.
So
But
in that case, you cannot use NAT when the H is enabled.
okay.
So that is
Thank
the
you.
problem. So okay. So let me go to the ESP tunnel mode. Here we have our web server, and here we have our VPN gateway, and here we have our IPSEC tunnel. This is VPN gateway 2, and this is our, let's say, database server. So here our encryption domain is this, because actually we are encrypting traffic initiating from this to this and this to this. I mean, both ways, vice versa. So these two are communicating through the tunnel. This is a tunnel. So that's why we are calling this a tunnel mode, because here in the tunnel, the tunnel IPs are these IPs 172.16 to 1.1 and the 172.16 2.1. Okay. So let me draw the ESP tunnel mode data packet. Here, this is new IP header, and this is ESP header. This is old IP header. This is TCP header, and this is data, and this is ESP trailer, and this is ESP ICV. But okay, integrated check value. So this is the ESP tunnel mode data packet.
Yes.
So here, this part is totally encrypted. This is totally encrypted. And this part is checked for the integrity. But as Anushana asked me, so when it comes to ESP, we have encryption. But when it comes to AH, we do not have encryption. So in that case, let's say encryption or the confidentiality.
But we are not encrypting the IP, right?
Yeah, actually, Anushana, when it comes to AHO, anyway, AH, we do not have encryption, but we cannot do the encryption for the new IP header, because anyway, we have to have a IP header in order to route the packet in the network through the network. So here, this cannot be encrypted anyway. So this should be a plain text anyway, because in order to understand the traffic path, so this should be there. So in that scenario, this is encrypted. All IP header is encrypted, because there is no problem, because once this packet is received at the VPN gateway is going to remove this and this as well. So then it sees this all IP header. So that is the actual destination. So actual destination means in this diagram, so traffic is coming like this. So then, So then the VPN gateway sees it has a all IP header. Once it removes the new IP header and the ESP header, so this packet can be this packet can this packet can be routed back to the okay. This packet can be routed back to the database server, since it has IP header.
Yeah.
You got the idea, right? So this is the this is the whole IP header. This can be used in order to route the packet back to the database server, because that database server is the actual destination, not the VPN gateway. Actually, VPN gateway is just a VPN gateway, so it does the encryption and decryption. So in order to route traffic between the VPN gateways, they are using this new IP header in tunnel mode. So that is the theory behind this. So let's configure this tunnel mode now and check the packet capture. So let me go to the first VPN gateway. So So now I'm going to Raccoon configuration first. So let me go to because this is fine, because anyway this is the phase one, so we don't have to change anything. But since this is the actual encryption domain, actually we have to change this. So let me change this to our Windows machine IP address 192.168.100.50. So then here 192.168.200.50. So that is fine. So this is phase two. Let me restart the Raccoon service. Sorry. Okay, so let me go to IPSEC tools. So this is a security policy database policies. So here we have to tell what to protect. Okay, you can remember this, what to protect. So we have to protect our IP Windows machines. So here I'm going to put 192.168.100.50, and here the destination is 200.50, because this is outgoing, outbound, right? Outbound with respect to our VPN gateway 1. 200.50. So then the VPN gateway says I'm receiving a packet from 192.168.100.50, and this is going to be outbound direction. So then my destination, or this packet destination, is 200.50. So then it checks this, and it says this should be IPsec treated. So it's going to do the whatever the encryption and you know everything. So here this should be tunnel mode. So once here, sorry, this is tunnel mode. So then VPN gateway knows this is tunnel mode. So then I have to put another IP header. So it's going to put its IP address as a source 172.168.1.1, and destination is 172.168.2.1. So these are the tunnel IPs. If you have any questions, just ask me. Okay, so this is inbound direction. So let me change this. So our encryption domain, or the what to protect. So that this is security policy database. So that means what to protect. So the protection should be 192.168.200.50. Actually, this is when it comes to inbound direction. Actually, this is not encryption. Actually, this is going to be, there's going to be a decryption actually, because when the packet receives at this VPN gateway, it says this is it is going to treat this as IPsec packet, since this policy database has this entry, and it's going to decrypt that. So in order to decrypt that, it is going to check the SPI value and the source and destination, and also the security protocol, and it's going to check the security association database and get the security keys, encryption keys, authentication keys, and what you call encryption algorithms and all. But can someone answer me this question? So I think you saw that there was an encryption key as well as a authentication key. So do you have any idea what is authentication key is? Encryption key, you know that in order to do the encryption, we have to have an encryption key. But what is authentication key? Because you saw that in Vaishak, I inserted that into the decryption area.
Authentication, when they are establishing, they shared that one, right?
Yeah, did you check that principles of information security? Because this is I'm checking the first today I checked the first lesson. There's a Mac and HMAC. Mac and HMAC. Yeah. Did you see that? In that case, we have to have a key. We have to have a key in order to authenticate the peers. I mean, authenticate the authenticity, because once it's shared, so then that when it generating the hash, that key also included in the hash. I mean, when generating the keyed hash functions. So I think you saw that MD5 HMAC. So that means that we have to have a key for the authentication as well. I mean, in order to do the hash. So now it's fine. So 192.168.200.50. 192.168. Sorry, this is inbound, right?
150.
Okay,
100.
150. Next. Okay, then I'm going here. I'm going to change that to tunnel mode. And this is 172.16.2.1, 172.16.1.1. Okay, it's fine, right? Because sometimes I'm getting
Yeah.
confused. Okay, now it's fine. Okay, let me save that. Let me restart. Set key service. Restart. Okay, it's fine. So let me go to the VPN gateway 2. Nano etc. First, let me change the raccoon configuration. Okay, here this is fine. Since this is phase 1, so let me go to phase 2. So then the address should be this is an encryption domain actually. 192.68 200.50, right? 200.50, right?
Yeah.
Am I right? Okay. So
Yeah.
then here 192.168 100.50. Okay, so that's
50.
fine. Okay, so let me save it. So let me restart the raccoon service. Okay, so let me go to IPSEC configuration now. IPSEC tools configuration. This is what to protect. Because I'm repeating, so then in the exam, when the question is there, what is SPDs, then you will be able to remember that I was always telling that what to protect.
Speed to
That's
protect
why I'm repeating.
SADs.
Okay, this SPD. So this is what to protect means. Yeah, traffic from 192.168. This is from 200. This is outbound direction with regards to VPN gateway 2. So that means behind the VPN gateway 2, we have the Windows machine with the IP 192.168 200.50. So that means since it is outbound, source should be 200.50 and the destination should be 100.50. 100.50. Okay, so outbound, and let me go here and change it to tunnel mode. And this is the tunnel IPs 172.16.2.1, 172.16.1.1. Okay, okay. So let me go to this one. This is inbound direction, so that means 192.168 100.50. It should be 200.50. 192.168 200.50. Okay, so let me go here, and this should be tunnel, and this should be 172.16.1.1, 172.16.2.1. Actually, these configurations actually we don't have to remember because these are just the implementations. I mean, related thing. When it comes to the Raccoon and IPsec tools, this is the configuration. When it comes to Palo Alto firewall, there's somewhat different configuration. When it comes to FortiGate firewall, we have somewhat different. When it comes to Strong SAM, we have somewhat different configuration. The only thing is you have to understand the concept, because I've seen most of the new generation, they do not understand the concept. They just try to remember the configuration commands and all. So that is not the way we have to do. I mean, we have to understand the
Yeah.
concepts only. If you know the concept, you can configure Palo Alto, you can configure FortiGate, you can configure IPsec tools, Strong SAM, or anything. If you know the concept, so that is the best thing to do. So let me restart this. So set key restart. Okay. Now I'm capturing the traffic. Now you can see now the ESP packets are there, but the thing is you cannot see any packet structure.
Thank you.
You cannot see the packet structure. So this is the packet structure. Here you can see our Ethernet header and IPv4 header and the encapsulation security payload. That is the only thing you can identify. So what I'm going to do is I'm going to do the decryption in order to identify actual structure of the packet. IPXFR in state. Do you have a you have a idea? You have an idea that this IPSEC can be decrypted, but the thing is actually I'm getting these keys and all from the VPN gateway or the host itself. So since the intruder or the eavesdropper does not have access to these configuration and all, so IPSEC cannot be decrypted. But here, since I have access, I'm getting these details and do the decryption. So here I'm going to get the this SPI value first. So let me go to edit preferences and protocols. ESP edit. Okay, so here I have to remove this. No, I'm going to add new entry IP and source is 172.62 dot. Sorry, 1.1. Destination. And actually, the other thing is, since I'm putting this source and destination and the SPI, I'll show it to you. So that means only one direction is going to be decrypted because these details are relevant to one direction only or the one SPI only. So we should be able to see some packets are still ESP.
Yes.
I mean, packets initiating from the 2.1 to 1.1 cannot be decrypted using these details. So I think Udeshika, you can understand these bidirectional,
Yes,
unidirectional thing.
Yeah. Yes.
16 2.1. Okay, so then the SPI, I think I copied it. So encryption, I think since we haven't changed, this should be I think triple this and encryption key. Let me get the key. This is the key. Sorry, encryption key. Okay, so authentication, I think we use HMAC MD5 and authentication key. This is a authentication key since this is HMAC for Mac. Because I mean, in Mac can also Mac can HMAC, I mean, message authentication code and hash method message authentication code. We need to have a key in order to generate it. So I inserted that. Okay, now we can see the problem is we can see ICMP, right? So see this some packets are still ESP.
Yes.
And check the this SPI. This is I think 85D, right? So let me go here.
Yes.
85D is this, not that one. So because of that, this is not encrypted. I mean decrypted. I think it's better if I can start the capture and send some. I mean. TCP traffic, because otherwise the packet structure is going to be, because ICMP is not TCP or UDP. So because of that, I'm going to use RDP in order to connect to the remote machine. So now it's fine. So let me go here and stop it and let me filter using the port number, because the port number should be 3389. I'm just filtering the traffic, RDP traffic. Okay, this is RDP traffic. You can see this is SSL. See, this has been decrypted, and the most important thing is you see. Let me go to the diagram first. So here we must have two IP headers: new IP header and the old IP header. Okay, so let me go to the packet capture. See, we have IP header here and also IP header here. So in between these two IP headers, we have encapsulating security payload header. And here our new IP header is a gateway IP, VPN gateway IP. Source is 172.16.1.1. Destination is 172.16.2.1. And our actual encryption domain IPs are 192.168.150 and 250. So this is TCP header. Let me go here. See, this is destination port, because when it comes to RDP, remote desktop protocol, the destination port is 3389. And here we have TCP details. Here we have the data, because in RDP they're using SSL and for the encryption. So because of that, this is encrypted. This encryption is not related to IPSEC, but this encryption is related to actual data. I mean this RDP encryption. So that is the thing. I think Udeshika, now you should be able to remember that bidirectional thing, because since we entered only one SPI details here, only the specific. Let me put ESP here. Only these are not decrypted. So the same thing happened in the gateways as well. In the gateway, they are doing this decryption and encryption using the SPI values. This SPI is somewhat different. So actually, we did this decryption and this decryption. What we have done is the same thing. The VPN gateway is also going to do. In VPN gateway, they are going to once the packet is received, so the VPN gateway is going to check the SPI value and the source and the destination and the protocol ESP or the H. So it's going to use those three details in order to locate the relevant security association database entry in order to do the decryption process.